All right, Heidi there. We're going to do day 3 today. It's a little more from yesterday, right? Same, more of the same, but a little more difficult. So we've been working on logs, and what do you remember about if somebody asks you and they come up to you and they say, hey, what is a log? You know what a log is?
Exponent.
Yeah, you just tell them it's an exponent. Okay. Yeah, Star Wars going on in the hallway there. It was just a really big spring. So an exponent. What are we doing? We're just finding exponents. We're evaluating. If you evaluate, like right here, we have the log of 27 base 1/3, and you know how to speak the language. You know how to read that, right? It's the log of 27 base 1/3. We're just finding an exponent. We're finding the exponent that would make this true. The statement, if you wrote this in exponent form, 1/3 to some power equals 27. So really what we're doing today is kind of more of the same, a little more difficult. How do you take 1/3 to a power and change it to 20 to make it equal 27? It's got to be negative, yeah, Dylan? Yeah, negative will flip it, so that would make it 3 over 1. If the exponent was negative, it'd take the reciprocal, and then 3 over 1 to the third power would be 27. Good. So some of you, like I said, are like, yeah, I got this exponent stuff figured out. It's got to be a negative, and it's got to be a -3. Boom. Some of you want a little more structure and you want to rewrite it with the same base, then that would be the strategy. So rewrite with the same base, and they're both powers of 3, so 1/3 is the same as 3 to the -1. The unknown I'll write as an x, and then 27 is 3 to the third. So really now we have the statement, that's the same as the statement 3 to the -x equals 3 to the third. So that will be true if we have the same bases like that when the exponents are the same. So when does -x equal 3? When x is -3. So all of that just to say -3. That's the value of -3. So when you evaluate the log of 27 base 1/3, you really found an exponent that is 3. Negative 3. Okay? Next one's a little different. Same process though. I'm going to rewrite it in exponent form. So I have 2 to the unknown power, x, we'll call it, is equal to 4 to the third. Now I know you can make that 64 and you can solve it that way as well. Right, so 4 to the third, you could say 2 to what power 64, and you could go that route. I'm going to show you a little different route just in case this was a little bit uglier of a problem. So let's say we have 2 to the x is equal to 4 is the same as 2 squared. So that's 2 squared cubed, right? And then from there, I have them written as the same base. So now I can clean them up and set their exponents equal. So that's like the same as saying 2 to the x is equal to 2 to the, is this 5 or 6 power? 6. So 2 to the x is equal to 2 to the 6th when x is 6. So the answer to the log of 4 cubed base 2 or the log of 64 base 2 is 6 to the 6th power. Okay. Log of 16 base 8. Well, that's going to be 8 to what power? That's an x, we'll call it. 8 to some unknown power equals 16. You know what the most common incorrect answer to this one is?
2.
Probably 2, yeah. Because like, oh, 8 and 16, oh, it's 2. It's not 2. Okay, 8 squared is 64. Let's think about our number sense here. 8 to the 0 is 1. 8 to the 1 is 8. And 8 to the 2 is 64. So where does 16 land between 1 and 8 and 64? It lands somewhere in between here, right? So my answer is going to be somewhere in between 1 and 2, right? and these are all non-calculator questions, so it might be one of these like, hey, I wonder what the answer is. Like it's probably not 13/20, probably not like 13/10 or something, right? 2 over 2 is the same as 1, so it's not going to be that. Good, square root of 8, but square root of 8 is not a perfect square. But I think you had the right idea. It's not a perfect square, but it's a perfect cube. See over here on this whiteboard, it's a perfect cube. It's written out. So 8 is a recognizable perfect cube. So you could think, oh, cube root of 8 is 2, and then 2 to the 4th power is 16. Oh, so it's 4/3. Okay, but maybe some of you aren't really that fantastic with the exponents where you can just go in your head like that. So let's rewrite them with the same base. So if I rewrite this with the same base, they're both powers of 2. So that's like 2 to the 3rd to the x is equal to 2 to the 4th. Okay, and if I continue that and clean it up a little bit, that's like saying 2 to the 3x equals 2 to the 4. And now I can take the exponents and find out where they're going to be equal. So when does 3x equal 4? Divide that both sides by 3 and you get 4/3 is your answer. That one was a little bit tricky. Does 4/3 make sense right here? Does it make sense that that's 4/3? Yeah, it's in between 1 and 2, right? So depending on how good you are with your exponents, you might be able to do some of these just mentally without writing it out with the same base. Or maybe you want to do both. You're really conscientious. You want to make sure you get them all right. So rewriting with the same base will help you. Okay, let's keep cruising along here. We're going to add a couple logs, but they're little happy logs. They work out to be nice, neat, happy answers. So when you see log of 16 base 4, you're thinking in your head, hopefully, 4 to what power is 16? So 4 to what power 16 is 2 plus, over here, log of 27 base 3, you're thinking 3 to what power is 27? That's 3, and 2 plus 3 is 5. Yeah? Isn't that right, Whistle Man? I'm whistling right now. Mushroom. Okay. No more whistling, please. Thanks. What about if the base is missing? What is it? 10. Good. That's the common log, base 10. Missing base? 10. All right, so now this is saying 10 to what power is 1,000? Do you need to rewrite those with the same base? You could if you want, but hopefully you can do this one mentally and just say that's going to be 3. 10 to the 3rd power? 3 zeros. 1,000. Again, over here, missing base is 10. Change the decimal to a fraction. 10 to what power is equal to 1 over 100, or 1/100th? All right, how do I turn a 10 into a 1/10? -1 power. How do I turn 10 into 100? Square it. This one's going to be a -2. No, it's not. It's a tree. Exactly. All right. Questions at all? Okay, something new here now. This is the natural log. Okay, so when you see the ln, you don't say ln. You don't. You say the natural log. Okay? Say it with me. The natural log. Not ln. You don't go saying ln. You sound really dumb when you say ln. The natural log. This is your log, the nat log. This is your log, Natalie's log. The natural log has a base of e. Yeah. E is some irrational number. We're not going to go into it, but the approximation, it's like pi, right? So pi has a repeating value, never repeats, or it has no repeating pattern. I meant to say 3.14159, blah, 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 blah. E is like approximately 2.71. It just goes forever, no repeating pattern to it. So there's some applications to E, but we're going to leave it at that for right now. And so this is the natural log has a base of E. So this technically, when you write the natural log, nobody writes the base in there, but it is E. So this is like the natural log of E to the fifth. What do you think when you see that? You think of E to what power equals E to the fifth? So E to what power equals E to the fifth? That seems kind of like almost a little too easy. Yep, it's just, that's what it is, just 5. This one's just 5. This one happens to be. Because I change it to exponent form. So when you change it to exponent form, you like the base to the power, or the exponent, the base to the exponent equals the stuff, right? So I have base, exponent, stuff. E to the question mark equals E to the fifth. That's why there's 2 E's. Natural log of E to the negative 4. Really what you're saying is E to what exponent is equal to E to the negative 4? What? It's negative 4. That just seems kind of too easy. Okay. Hey, real quick. Read that for me. Hold on. Oh, okay, not ln. Okay, good. The natural log. The natural log of 1. E to what power equals 1? Nope. E to the 1 power is E. 0. That's a 0. To the 0 power is 1. Okay. Give him a mullet. Next one's a harder one. This is the last one we'll do today. 2 to what power is equal to, yeah, this is weird. I'm going to change, instead of cube root, I'm going to change it to an exponent. So what is an exponent that's equivalent to the cube root? 1/3, right? So the cube root of 16 is the same as 16 to the 1/3. It's helpful to write the radical as a fraction here. So now I can rewrite these with the same base. So this is like saying 2 to the x is equal to 16 is 2 to the 4th to the 1/3. So 16 is the same as 2 to the 4th. Yep, then you clean that up a little bit. You have 2 to the x is equal to 2 to the 4 to the 1/3 is 2 to the 4/3. So when are these going to be the same? When the exponents are the same, and so x is going to equal 4/3. Yeah? Okay. Should keep going. We got some crustier questions on this page. I'm just going to keep going here because we're a little ahead of schedule, and I'll just wrap up the full notes. 3 to the unknown power, I'll say x is equal to 9 to the 1/5, right? 9 is the same as 3 squared, so this is going to be 3 to the x is equal to 3 squared to the 1/5. So 3 to the x equals 3 to the 2/5 when x is 2/5. Neat. Yeah, I'm going to pause. Let's see if you can do the next one. Gave you a little head start there, and let's see if you got this right. So we got 1/5 to the unknown power x is equal to 25 to the 1/3 power. Okay, now those both can be written as powers of 5. 1/5 is the same as 5 to the -1. So 5 to the -1 to the x, and 25 is 5 to the 2nd to the 1/3. So if I clean that up a little bit, this is like saying 5 to the -x is equal to 5 to the 2/3. So x is going to be, or this log is going to be equal to, well, when does -x equal positive 2/3? When x is negative 2/3. Did anybody get it right? All right, nice job. Good. Last one here. The base is missing. It's a 10. So this is saying 10 to what power is equal to the square root of 1,000, or 1,000 to the 1/2. All right, so square root is 1/2. That's the same as saying 10 to the x is equal to 10 to the 3rd to the 1/2. And so 10 to the x equals 10 to the 3/2 when x is 3/2. Hey, hey, look at there, we did it. We got through everything. 17 minutes, more fun with logs. Kaylee? Oh, yeah, so you made the 25 1/5? Sure, that's fine. So you just made that a negative 1/3? Yep. That works too. All right, question? Not yet. No, no. Because here, the substitution that was made was 10 to the 3rd is the same as 1,000. You know? So I took this and I wrote 10 to the 3rd instead of 1,000. And then that's a 2. So that's 10 to the 3/2. If you go from radical form to exponent form, the square root of 10 to the 3rd is the same as 10 to the 3/2. No, it's not a perfect square. 1,000 is not a perfect square. Alrighty, signing off.